What we also did is what they're asking us to do right now. Take these three sequences, rearrange it, and put it into this function notation. When you guys look at your quiz, when you guys look at your homework, every time I tell you guys to do function notation, right behind it to kind of jog your brains, I put right behind there what I'm looking for. And what I want you to keep, again, thinking about is that ax plus b. If it's not an ax plus b, put it in that form. And every time we've done this, I know it's repetitive, math usually is, distribute, combine like terms. That was what we kept doing and doing and doing. So, as we do that, all right, let's work this one more time here. Let's take this top one here. This will become a nice warm up to get our brains jogging again. Let's take this top one right here. Let's move it off to the side. And I want you to, again, take this in this arithmetic form, do something to it to make it look like that. Ax plus b. And don't tell me it's a new skill. We've done it, we've done it, we've done it. You did it back in 5th grade, 6th grade, 7th grade, 8th grade. Yes, you have, Victor. Okay? You weren't there that day, maybe. Or yeah. Okay. So let's go ahead. We use our parentheses first. What do we say to use them for the parentheses? What property? Yep, thank you. We're going to use our distributive property. Anytime we see parentheses, we distribute. All right, let's distribute now. That 2, what's that 2 going to do? Yep, drops on down. Here's where you can watch your arithmetic. Negative 4n, and what's my next number going to be? Negative or positive? Thank you. Negative times a negative right there makes it a positive 4. That's all we did, and then we combine like terms. You do this enough times, it is the same pattern. Now eventually we'll switch it up, but for right now it is not. The negative 4n are not like terms, is not like term with the other two. So we said we just drop it on down, and this is back to your arithmetic. 2 plus 4 is, yep, 6. That's what we want. Does that look like where we want to be at now? Ax plus b? It sure does. So right below that, okay, now I've been saying y equals, or you can also say f of x equals. You'll see it written both ways. It's not a big deal. I'm not going to get that picky. All right, so f of x equals negative 4x plus 6. And I'm pretty sure if you flipped it back a couple pages, that's what we got the other day. Okay, so that's one skill I'm going to test you on Monday when we come in. Okay, let's do one more here. Let's take the one on the right here. Okay, 4 plus 2n minus 1. Let's do that last one. And then we'll move it on here. So when I say put in function form, ax plus b, that means triggering you. Okay? You guys are growing up being slope-intercept form. Ax plus b, that's all we want. We got parentheses, so what do we got first off? Yep. It should be an automatic. You should be having dreams or nightmares, however you want to view it. Distributive property, combine like terms. The 4 just drops on down. And after we distribute, the same two terms should be likes. Okay? That negative 4, sorry, that negative 2 and that 4 will eventually combine. That 2n is not a like, is it? So that comes on down, and 4 minus 2 is? Yep, and that's that arithmetic skills. I know I'm going to have somebody type in 6 and negative 6. Maybe somebody throwing an 8 or negative 8. I see a lot of weird stuff. All right, but you know what 4 minus 2 is. There we go. Let's put it now below there. Y equals or f of x equals. I'm really fine with either one of those. That's where we want to be at. Okay? You do that for me on Monday, you'll be looking good. That's one thing I'm going to test you on.
I'm going to be here on Monday, sadly.
Oh, that is so sad. I'm not sure if I'm able to sleep the night before now, knowing that. Oh, no, that's cool. I'll sleep just fine. All right. I'll catch you on the next day. All right. So let's keep talking here, and then we'll look at the next piece. What hopefully you're noticing, too, is when we rearrange this, earlier, way back a couple months ago, we say that -4 was considered to be the common difference, right? And over the last few days, we've been noticing that that common difference is also the slope that we've been finding. So when we look at this here, letter C, verify that constant difference is the same as the slope of the linear function, and that's what we're seeing. All right, so let me drag this up a bit for you. The common difference, which is that d value we were just talking about, oops, that d value is the same for the slopes. And the slope is that a value in that ax plus b. That should always be true. If it's not true, you're not doing something right. That -4 should be that -4 out front. That 2 on that last one we did, that common difference of 2, should be that 2 out front. On this one here, it's also a common difference of 2. If we rearrange that, that should be a 2 out front, and so on and so on and so on. Okay? I don't care about question B. Give you a second here, we'll flip it here and see if there's something worthwhile to talk about. Give me a second, because I know some of you are still writing. So that's one thing I'm going to quiz you up again on. Not just Monday, but the following Monday, eventually the test, eventually the final. The other thing I'm going to quiz you up on is, I don't care too much about that, but let's take a look at it. We got some time with that. Okay, we got the sequence 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. Go plot that out. Okay, what type of line are you going to create there? What are your eyes doing? Are they going up? 3, 3, 3, 3, 3. Are they going up? No. Are your eyes going down? 3, 3, 3, 3, 3. No. What are your eyes doing? Staying the same, right? Somebody just said it. What are we doing? Yeah, there we go. So we haven't really seen a sequence like that in our notes per se, but we've talked about constant lines before, right? So when we plot this out, the first term is 1, 2, 3, 4, 5, 6, 7, 9, 10. And let's just go by ones up top. I'll give you a minute. I'll pause out there. Let's plot that out. And as I keep telling you to trust your eyes, you just told me that you weren't increasing or decreasing. You were doing the other option, which was staying constant, right? So go plot that out and confirm that you get yourself a, what type of line? Horizontal or vertical? Make sure you know the difference there. Yep, it's horizontal. I got some of my kids in my geometry class saying that this was, what was he doing? He was doing this motion and saying this was vertical. Okay, so make sure you know the difference. This is what? Horizontal, and that is vertical. So I know it's small things we laugh at, but let's make sure we got it right. So all those horizontals, like you said, should be, bless you, should be constant, giving you that horizontal line. What does it look like as a table? The first term was 3, 1 comma 3. The second term was what? 3, 2 comma 3. The third term was 3, 3 comma 3. Fourth term was, and obviously we know what's going on there. Okay, so we've done that before, but we never ran a sequence quite like that just yet until now. Give you a second there. Now, off of this one here, okay, let's talk about putting this together and writing it in function form. So what I want us to do now is we want to take this graph. We did this some point last week, I think. We played the matching game, that sequence to match that graph and so on. I want to make on that page something that looks like this. So when we do that on number 2 here, what is my first term? What are we starting off at? Our first term is got a value of 3, right? And how much were we changing? To go from 3 to 3, 3 to 3, 3 to 3, how much are you changing? None. Give me that as a number. 0, right? You're not adding anything to it besides 0. So the common difference we say is, and again, we haven't run into one of those before. Now we are. Who cares? Now let's make the equation. When I keep saying make the equation, this is our old school stuff now. Got to know where you start, how you're moving. What did we just say we're starting off with? We're starting off with a 3. And how are we moving? 0. You guys did this before, and you guys did well with that. Okay, so don't tell me that's not new. All right, that's good. That starts it off. But now what do they want us to do? We want to put that thing into function form. Okay? So here's where we're at in our sequence form. We now want to move that into that function form we keep wanting to be at. So I'm going to drag it off the bottom here. I don't care about this crap. All right? I want you to use the same set of skills we've been talking about. Make that look like AX plus B. So let's do that. It's the same thing we just did today. We did it last week. You've done it since 5th grade. Use that distribute property. What is 0 times anything, people? So 0 times n is 0. 0 times -1 is. So when you kept saying 0 and 0, do I have an n to write down at all? No, 0 times anything means it's gone. It's 0. Don't put an n there. You put me an n there, you're telling me 0 times n. If you do this, you're telling me 0 times 1 is 1. Is 0 times 1 1? No, you broke math. Don't break math. Okay? So don't put an n there. It's gone. Now we have like terms. What's 3 plus 0 plus 0? 3. Just 3. Well, that's a little weird because there's no variable there, right? Which is fine. We did it all correct. We're not wrong. But if you remember, very beginning of the year, we were learning to use our graphing calculator. And on our graphing calculator, one of the things I had you guys learn to do as you typed them in, I gave you an equation that looked like this. I gave you something that was, I don't know, x plus 1, and we get a linear graph. Okay? Then we did something like x squared, and we got a parabola. But then I gave you something like just a single number, and you typed it in, and what do we get? I might type in that y equals, I believe, on my decimal stuff. Hold on. We got just a horizontal line, right? So that's what's happening here. We didn't do anything wrong. The x is going to drop out, and every time the x drops out, you are going to get a horizontal line. And what did you tell me at the beginning of that problem? You told me that it was going to be constant. Okay? You told me it was going to be constant, creating a horizontal. That's how we try to connect those things. All right? All right, let's flip it. We're going to do something that we normally don't do. Let's go, keep flipping. And I want to go to the page that says your practice, your assignment page. Because we've exhausted the notes. And I want to do the last thing here with you is, what page is that? M2-21, everybody. Let's turn to number 2 right here. So we kept rearranging to x plus b, and the other thing that we talked about on Monday was linear or not. So let's review that from Monday. These 3 tables, linear or not. Let's do that. Letter A. All right, to determine if it's linear or not, we now, I had said I always look at these y's first. And I ask yourself, hey, what are your eyes doing from 14 to 18? How do you go from 14 to 18? Add 4. That's right. Nice beat there. 18 to 23, what do we do? Add 5. 23, 29. Now, is this looking helpful? No. Now, I always want to check the x's as well, and I want to see that consistency happening on the x's, but it's got to be on both sides. 3 to 4 is A, 4 to 5 is A, 5 to 6 is a, okay. But why is this not linear? What is screwing it up here? The y's, correct? So what are we going to classify this as? A function, a linear function, or not a linear function? Correct. This is not a linear function. It's got to be 4, 4, 4, 4. 5, 5, 5, 5. Okay. What's that? Now, letter B. Do we have a linear function there or not? A crapped out. Let's look at B. 2 to negative 1. What are your eyes doing from 2 to negative 1? How do you go from 2 to negative 1? We're going down the amount and going down, yep, 3. You're still going down, right? Negative 1 to negative 4, how much do we go down? Still going down. Negative 4, negative 7 is? Okay, is this one looking hopeful? Okay, let's check it on the x's. What am I doing on the x's? Is it consistent there? Plus 1, plus 1, plus 1, plus 1. So we bring it all together, linear table or not? Yes, it is. Okay. Let's go to the last one. And we've done several the other day. We just did a couple now. You should have the idea again. I'm going to quiz you this up on Monday when we walk in. Linear table here or not? What are your eyes doing from 11 to 16? Going up, how much? 5. 16 to 21, do I see a 5 again? 21, 26, I see a 5 again. This is looking promising. Make sure you check the x's, because I believe on our next lesson, I'll change up the x's on you. And that thing's a little funky. But that looks good, doesn't it? So we have ourselves a linear, yes, it's a linear table. Okay. So if you can do that for us on Monday, on top of putting into x plus b form, you guys are looking good. Okay, that's what I want to check in on you with. All right. Now while we're here on this page, let's get the bottom here on this same page, number 3 here. All right, on number 3, this is where things can get a little funky. On letter A, we're going to talk about this more next week. I'm not worried about that at the moment. Let's look at letter B though. Letter B says calculate the rate of change. And when we say the rate of change, that's just another way to say go calculate me the slope. Okay? Rate of change is rise over run for what we've been doing. So find me some nice points on there. Where's some nice points? Highlight it and make me those stairs. Looks like a nice y-intercept and doesn't look like a nice x-intercept. Those look pretty nice. That's all I need. How far is it from that to that? What's the rise? What's the run? Make the big triangle. How much am I going down? I'm up here at 4. And I go down how much? Down is negative, yep, 4. And then I turn, and how much am I going to the right? Yep, watching those x's from 0 to 12. And to the right is what? Positive or negative? So how do I write that slope? 12 over negative 4 or negative 4 over 12? Thank you. The rise over the run. Always reduce it down. Your brains, some of it's going to tell me negative 3 is the answer here. But it's not. What's it going to be? 1 over, right? So as Chloe's saying there, it's going to be a negative 1/3. 12 divided by 4 is 3, not 4 divided by 12. Okay? Those are those elementary skills we keep telling you that come back and haunt you a little bit of time. All right? We got that. Let's write the equation. Let's finish this thing off. To write that equation, I need to know what the slope is. Check. And what's the other piece of information I need to know from this graph? It's always about the slope and the y-intercept. We just identified the y-intercept up here. Which number represents the y-intercept? Right there at the 4. It crosses the y-axis, duh. And just like we've been doing, ax plus b, ax plus b. So what's the slope? What's the y-intercept? Negative 1/3 x plus 4. Okay? You do that for us, that's nothing new, is it? We've been doing that one as well. Just a nice one to review that on and connect to what we've been talking about. Okay? Let's see if the other page has anything worthwhile for us. This does. Alright, last page here. Okay, I'm going to pause. Get your calculators out. Okay, if your calculator is Desmos, bring up Desmos, please. The other thing I'm going to quiz you up on is, can you plug it into your calculator? Can you evaluate? So on the next page is where we'll finish things off with the evaluations. We've been doing that recently with the predictions. We did this at the beginning of the year, and we're going to keep kind of just using it. Make sure you know how to plug that into your calculator. You even know where to plug that value in, and then type it into your calculator. Okay? So as we look at on this page, again, you bring up Desmos if you don't have your calculator there. I myself have to use Desmos, okay, because I don't have my graphing calculator on here just yet. No big deal. All right, give you a second there. Come on. Close in for me. Goes too big. No, I just did that. All right, let's take a look here. On that first one at the top, you should have Desmos pulled up or your graphing calculator pulled up. When I say evaluate f of 0, where's that 0 going in at? It's going for the x, and I always use those parentheses. We did this, I know, reviewing last week. We've had a little bit of practice each day from there. Now go to your calculator. Don't get lazy here. Type in exactly what you got written there, okay? 3 parentheses. You better use those parentheses on me. And then what do we have? Minus 10. If you can do your calculator correctly, you all better be getting negative 10. If you're not getting negative 10, this is time to raise your hand. Redo that now, but now what do we want to plug in? We want to plug in the value of 5. So type it in for the next one. 3 parentheses, 5, and then what are we doing? Minus 10. And if you did that correctly, what you should return, you better be getting a 5 right there. If you're not getting a 5, you don't know how to use your calculator. That's sad. It's an easy skill to learn. Number 2. That's a weird one. What am I missing on 2? What am I missing there on 2 compared to what we just talked about? Not so much that. We had an X on number 1, right? But do I have an X here on number 2? So I've got nothing to plug in there for 0, nothing to plug in there for negative 2. Now let's think about this. We just talked about that a few minutes ago. What type of line do we get with just the number 6? Constant. It's horizontal. And I think we got what? 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, right? And on this one we're getting 6, 6, 6, 6, 6. Uh-oh, that's not good. 6, 6, 6, 6, 6, 6, 6. So what that means is, no matter what you type in, it's going to stay 6. You get 0, 6, negative 1, 6, negative 2, 6, 1, 6, 10, 6, 15 million, 6. That's what's going to keep happening. We don't have that X in there. Last one we do though. Last one we got a X. We got 2 X's. Who cares? Wherever I see an X, what do? We plug in that number. In this case, we plug in a 0. Let's finish this thing off. Type it into your calculator, exactly what we got written down. What's that? 7? Yep. Victor's saying 7, and you better be getting 7. All right? As you type that on in, using those parentheses, you better be getting, bless you, you better be getting 7. If you're not getting 7, raise your hand. We'll come around and help you. Bless you again. Replace the last one with a 0.5. So I'm going to go do a type of 0.5 on in. And check me as well, Victor. Did you get a 10 out of that? Somebody else get a 10? We got some thumbs up going there. If you're not getting a 10, please raise your hand. Those are the easy ones to knock out on your quizzes and tests. There'll always be some questions that might challenge you, but those are the easy ones to knock out. Okay? Those three things are what we're going to quiz you up on a mini quiz on Monday when we walk in. That right there, determining if the table is linear or not. Okay? And then the other thing is, what we led off today with, change it into function form. Okay? We can do those three things. We're looking good for the first lesson. Okay? All right. So before we get to the assignment today, okay, let's do one of these. All right. Let's do a little kind of closing there on things. All right, let's take a look on that kind of closing here. So on that quiz Monday, number 1 and 2 is what I'm about to ask you to do. Okay, you can't do that on your own. You're done for. So I'm gonna put a minute on my clock there. I would tell you to take numbers 1 and 2, and take 1 and 2 there, and put it onto function form. 1 minute and go. Put it into function form, ax plus b. Nothing new. Don't wait on us.
Some of them are different.
See if they pay attention. All right. So let's check your work here. There you go. Make sure you realize maybe. All right. So let's take a look here. Can you put into function form? What's the first thing we got going on here is, what are we distributing on number 1? Not -6. There's a -1 hiding there, right? So -6 comes on down. What do you distribute now that -1? We talked about those -1s hiding there before. And then -1 times -1 is a, yep, +1. Did you do that correctly first? Then, if you got that correct, cool. Add up like terms. These are the mistakes happen now. -n comes on down. But -6 plus 1 is. Make sure you're checking yourself with the calculator. I'm going to see somebody say 7 and -7 and 5, but the answer is -5. And then we put our final answer in ax plus b form. You can say y equals, you can say f of x equals. I'm fine with either thing. That's what I'm looking for. Okay. Now, I can see somebody screwing up that -1 in that first one. But the number 2 is pretty straightforward. What are we distributing on number 2? Yeah, -2. 8 drops on down. Watch your arithmetic as you distribute. -2n and -2 times -1 is a, okay, yep, it's a plus. That's your calculator, check yourself. Combine like terms. Right there, 8 and 2 don't have variables. That brings together. Okay. Did you put that as an answer? Are you gonna type that in on Monday? If you are, and you type those in, you'll be good to go. Okay. do that, like I said, you'll be fine. Now let's flip it to the back side if you haven't done that yet. Alright, the other thing, like I said, is there a linear function hiding there or not? Think about what we just been talking about. Got another minute on my clock, not 10 minutes, another minute, go. Answer yes or no. Do we have a linear table there or not? Show me that work. Alright. Show me that work. Alright. It's taking longer than a minute. You got some issues. Alright, Ari. What'd you say for that first one there, letter A, yes or no?
Yes.
Yep. So what I saw in Ari's paper is exactly what I'll be looking on you guys. How are you moving? Check. Sorry. Yep. 15 to 8 is going down by how much? And see if I get the consistency there. -7. 8 minus 1 is? Oops, sorry. 1 minus 8 is also a -7, right? Do I get another -7 up here? Yep. That gives me another -7. So far, so good. Over here, I better see that other consistency happening as well. Yeah, Tristan.
+1.
And if I don't see that consistency, then we say it's not linear, but we have consistency, right? So Ari said it was linear. You can do that for us? You're good. All right. Ari, what did you say in the last one there? Why did you choose not linear, Ari? Yeah, what are we doing here? 4 plus 4, right? And then what? And then what? Yep, and so on and so on and so on. Now, sometimes that's actually okay, as we'll see later on when I change up the x's. But that's not happening here yet. So I get that +1 again, right? But there it is. As I already said, it's not linear because it's screwing up right here. And that's it. Okay. So do that for us. Like I keep telling you, you'll be fine for Mondays when we do this. Anything else? All right, let's do assignment. Okay.
I didn't get the first page.
The assignment meeting?
I didn't do the first page. I forgot
Oh,
to.
okay. Well, go ahead and do that. All right. I'll flip it back over for you. Alright. Give you guys some time to get ready to work here. But on this assignment here. Yep. No. Alright, let's take a look here. Yes. Okay. What's that? I try to have a good face. Alright, so as we get going here, okay, this is our quiz, mini quiz for Monday, okay? So, number 3, 4, we just talked about. Number 5, we just did on that closing just a second ago. We just did number 1 a few minutes ago as well in our notes. And then on the back side, number 5, boy, that looks similar, right? We've seen that stuff before. So that's the idea. Let's keep practicing, get great at it. Okay? So as you guys work here, you got plenty of time today. work on that. And, get that done, and bring it on up. And then make sure Matthew get his 3 unit 10 for that extra credit. Once unit 10 is done, module 2 will open up, and we'll do that tomorrow. Okay? Any questions? Alright, let's wait. You can calculate this, you can not.